handbook after the quest. That's number 1. And number 2, make sure you are ready for a couple of deadlines. Yes, there's going to be the quest, and you're going to need to do that. However, have you guys noticed I have a cell phone chart as you walk in the door? On test or quest or quiz days, you need to, before you even get to your seat, put your cell phone, if you bring it to class, up in the cell phone chart. Now, can I really quickly have a raise of hands of people who are like, I never bring my cell phone to class? 1, 2, 3, 4. Okay. So I'll double check with you guys, making sure that you don't have it. But I'll know to expect you guys not to have yours, but everyone else needs to go up there. Now hold on, wait a minute. Where do you put it in the chart? You guys notice your seating chart is kind of right here on the cell phone chart? Group 1 is group 1. Group 2 is group 2. And then group, well, we don't have it. You guys, go by where you're seated. Group 3 and 4 and 5. Your numbers are different because other classes go all the way across because they have to fill it all up. But your cell phone goes in your seat. Does that make sense? Okay. So for example, Jaden, where are you going to be putting your cell phone?
4.
But which one?
The one right there. No, up. Yeah, that one.
Yeah. Just use the single seat, and then the girls behind him are the double seats. Does that make sense?
Yeah.
So as you walk in tomorrow, cell phone. Boop, got it. Okay. 2 more things that I need to see tomorrow. Your notes with a table of contents, all up to date in every single section, 1 through 5, copied down. So if you've ever been absent, you have to have it made up by the test. Why does that make sense? You're taking a test. If you never took the notes, you're kind of screwed, right? Okay, so when you come in, you put your cell phone, and then you're going to be bringing your composition books right up here to the front table. It's a little messy because people kept leaving things, and I don't even know what happened. However, there's going to be a composition book pile and a homework spiral pile. So when you turn it in, you get 100% on your composition book. Everybody in your groups, double check, open your table of contents, and talk about if you need to update anything for tomorrow. Go quick. Do they have the titles, the sections, and the page numbers? And if I was to pick any random section to turn to, would I turn to the right page and the note that starts at the top? So double check in your groups though. Make sure everyone's doing it right. Like show everyone. Just show them. It's quick accountability, but it's also if someone's confused. You're going to catch them now. They're not going to lose points tomorrow.
Functional form.
Okay, hold on. Where am I going to put the grade tomorrow? In the grade. So turn to the back, and if you want it to be your writing and not mine, you can go ahead and write chapter 1A as the first grade. The first grade is going to be chapter 1A.
So where do you put that?
In the very back, you've made a nice little table, a grading table, and you can put grade over 10. I'll fill in the numerator, but you can do it over 10. If you want to make it nice and neat and organized. Otherwise, I'll just write it in my messy writing tomorrow. But chapter 1A is going to be the first note check. That's tomorrow. You're putting your composition books up here in the front table. But I also said homework spirals, yeah?
Yeah.
Okay, homework spiral. Grab it out.
Yeah.
What needs to happen in your homework spiral by tomorrow? Well, first of all, table of contents. What do you need to have at the very front? Now, hold on. Why did we fold that page? Calculus kids were confused. I'm assuming you guys were too. We folded the page so that we could make columns, right? 1, 1, 1, 2, 1, 3, etc. And then over here, like 4, 5, whatever. Can you double check that people are actually, some people are writing the 1, 1 and then the page, and I'm like, no. Squish it in. Perfect, Alex. Thank you. Double check your groups are good. They have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and the page number is all in that nice little column. And if they don't, it's okay, but they know what they're supposed to have done for tomorrow. You don't need titles. But I do want 1, 1 through 1, 5. Wait a minute, wasn't that homeworks 1 through 5? It's going to be super easy for chapter 1. It's homeworks 1 through 10. But then starting in chapter 2, 2.1 is going to be homework 11. Well, we're going to do chapter 1D. So then we'll do 6, 7, 8, 9.
Are we supposed to write homework number 1, number 2, number 3?
Yes, please.
Okay.
You have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. So that's homeworks 1, 2, 3, 4, and 5. And then page numbers. So they're not specific on that. Nope, just the chapter.
Wait, do we have a grading box on the
Nope, because the back is your workspace. So, and the homework spiral is not quite as big a deal. I don't mind writing your grades like in your homework spirals, you just need fit in the first column, 1-1 through 1-5, homeworks 1 through 5, and the page numbers that go with them. Double check your groups, make sure they're good. I just don't want to take off points unnecessarily. Now, what needs to have happened, because a lot of you guys have already submitted all of your homeworks on Google Classroom, right? And those were me grading, checking that you've attempted it by the deadline. Come to class, you have questions ready, you've already tried it, right? So what am I checking when I collect your homework spirals? A, that the pictures you submitted are actually a real thing and they're really yours and they're in the homework spiral. Think about it, someone submitting someone else's pictures. Yes, it's happened and it's really sad when I have to call not for something. But that you actually have a homework spiral and you've actually been doing homework. But also B, what else were you supposed to have added to that initial attempt?
Corrections.
You're supposed to have been grading in a colored pen all the evens, right? You're supposed to be showing questions. So maybe when you submit in Google Classroom, it's not perfectly done. But what were you supposed to be getting done when you came to class the next day or after school or during lunch? Those questions should have been corrected or answered. Does that make sense? So when I grade your homework spiral, I'm just saying, okay, cool. At this point, has it been attempted and graded and corrected? Does that make sense? And I'm not super picky with it. If there's still one somewhere that's like kind of incomplete in the answer because you weren't exactly sure about that whole like sending the box in the mail and the girth and the perimeter, like as long as you showed me attempt and you graded and showed the correct solution, even if you're not solid on it, I'll still count it. But there shouldn't be like gaping holes or problems that aren't finished or homeworks that aren't corrected. Does that kind of make sense? Take like 30 seconds, turn in your groups, and look at each other's homeworks and just be like, hey, it looks good, you graded, you corrected. Sometimes my words don't translate, and some people turn in stuff that's incomplete because they didn't know. So help your group out, make sure they understand. Is number 2 zeros? Should have been. Number 6 is odd. Strange? No. Origin symmetry. Number 20. Oh, that was mean. We were supposed to factor a cubic polynomial, except what made it easier? Well, there was. Careful, not perfect. There was a difference of squares. But before that, did you guys have to group? The cubic could have been super nasty if you guys didn't group. But if you grouped and saw that there was an x squared in common and a negative 9 in common, and then, an x minus 4.
That's not the problem.
How did HPrecalc not tell me this? It was the wrong problem? We should sue.
We just not do homework anymore.
Okay. Just because there are a couple typos doesn't mean that we throw away our $200 books and do something new. All right. And you have a teacher that can look out for you. Breathe. So this was your number 20?
Yes.
Oh, so I didn't give you the cool cubic one?
No.
Oh, that's sad.
Let's do it.
Well, it's all right. Okay, number 20. Ooh, what's the GCF? It still would have been hard. It's a quartic. Okay, if you pulled out the squared. Ooh, did some of you still get stuck?
Yes.
Some people got stuck. But some of you didn't. So those of you that didn't, walk me through. Hold on, pause. Let me take out the x squared. You get a 9x squared minus 25. How are you supposed to keep going, even though that is not a trinomial? It was a lot. Have you ever factor a squared minus b squared? They're both squares. A plus b and a minus b. Without that, I don't know what you would have done. That would have been weird. Well, I guess you could have done 9 quarters. That's 175, right? 9 quarters. And then 0. Ooh, 0 is my middle term. I guess we could have figured out that. And we would have gotten 15. No.
I don't like that.
Oh, wait, 9 quarters is 225.
Wait, what would you?
There we go. Because you could have multiplied a times c for the modified x method, and your middle term is technically a 0x because it's not there.
I still like.
And so you could have done a. I'm just saying, if you didn't see it was a difference of squares, there was another way to go. You could have put 0x as the middle term.
That's really confusing.
Yeah, it is. I was just trying to help those who didn't see it was a difference of squares. There was another way. I hate it when someone gets stuck in a problem, and it's not always their fault, but they're like, I couldn't go any further. I'm like, but could you have thought about it a different way and maybe tried something? Now, sometimes literally it's like, if you didn't think about it, yeah, I'm stuck. There's no place to go. But sometimes I'm like, oh, well, there was a way to go. Okay. All right. Point proven. Number 20 is a typo. Can you guys hang with me for like 2 seconds for me to put in a line so next year I know it's a typo? Let's do a shape. Let's do a line. All right. Well, that's sad. Okay. Every year it gets a little bit better. Number 32 and 36, we were talking about decreasing and increasing intervals, right? X intervals. How left, how right. How do we do? You guys notice that 36 increase, then decrease, then decrease, then increase?
Wait, so every time they're talking about decreasing and increasing, it has to do with the infinity sign? Or not always?
Only if the graph goes forever.
Okay.
The one we had in our notes.
How do you know when it goes in the x value and when it goes in the y value?
For intervals, can we go back to the notes for a sec? With increasing and decreasing, always x intervals. So the rising and the falling, the increasing, the decreasing is explaining or is talking about the y's, but the x intervals tell me what portion of the graph.
So on the increase, it was starting at.
Was that for 32?
Yeah.
Yeah, 30 or 36?
So start 32.
32.
So it started at 2, so 2 is the x value, and then it just went up to infinity.
No. You're thinking about it wrong. Hold on. Does anybody have a question on 36 while I'm here? Yeah, I thought so. Okay, before we get to 36 though, 32. Do you remember the 2 to infinity isn't a point? So what we're talking about is starting at 2 and going until infinity. All of those x's will have parts of graphs that are going up.
Okay.
And then the other one was from negative infinity to 0. So we're talking about the left, right, where the
So
falling.
decreasing is good. Why wouldn't it be from infinity to, why is it negative infinity?
Because if you're thinking just the x values, this graph was falling for all the x's starting at negative infinity.
So that one would be negative infinity to up to. Okay.
Yeah, because we're going left, right.
Okay.
The decreasing, increasing are the y's. And so you can maybe see that a little bit better or further on 36. Because on 36, first of all, do you guys realize there's a vertical asymptote at negative 1? That would have been a struggle. Because some of you wouldn't have thought to break up the negative 1. But did you see the max at negative 2? And the min at 0? If you look at your answer key, they used negative 2, negative 1, and 0 as our breakers, or as our separation points. So, do you see how the graph is rising here, right? And rising here. So we have an increasing portion branch here, and an increasing portion or branch there. How do I describe how left to how right for this branch? How left? Negative infinity. How right for this branch? It stopped at negative 2. So how left, negative infinity, to how right, negative 2. And then this increasing branch started at, where did this increasing branch start?
0.
Yeah. And for how many x's is it going to keep increasing? Infinity. But where a lot of people got confused was not the increasing part, but the decreasing part. See my decreasing parts? It is decreasing from how left? Negative 2. But do you see how it only decreases? Who is this guy? Oh, it's the asymptote. It's the vertical asymptote at negative 1. So from negative 2 to negative 1, it's decreasing. And then the graph is now up here past negative 1, and it's decreasing some more. So it's also decreasing from -1 to 0, but I couldn't say from -2 to 0 because there's a break in between. X is not allowed to equal -1, so I had to cut it off on one side and on the other axis.
Why would there be an infinity sign?
Because remember, we're not saying where the graph is going. We're saying what portion of the graph. So what's the left boundary?
-2.
And what's the right boundary?
-1.
So we're not saying, because we're answering it with decreasing, so we're telling you what it's doing. It's going down. But that's not what we're showing you here. This is decreasing, and this is from left to right. And then same thing, from left to right is just -1 to 0. Yeah, it's all about using these x intervals instead of, we're not saying the range. We're not saying how high, how low. Instead, we're just saying how left, how right. Yeah.
So what's the bracket parentheses thing again?
Whenever we're doing intervals, and I don't even think I specifically said it, when we're answering with x intervals, for increasing and decreasing, we're always going to answer how left a certain portion of the graph is to how right. We're going to use words like decreasing, increasing, constant to explain what the graph is doing, but when we answer, we're saying how left to how right. And for increasing and decreasing, we're keeping it always open. Now, the back of the book might throw in some brackets in here, and if they do, I actually disagree with them. Big. I like what you're saying, I like what you're thinking, like it's getting straighter and straighter and straighter and straighter, but the reality of it is, theoretically, even though we wouldn't be able to keep drawing them getting higher and higher and higher, mathematically, it will always be getting closer and closer to a vertical line without ever actually becoming. Now, it's like within 0.00000000000 of a vertical line eventually, but it's still technically 0.0000000. That kind of makes sense. So it's like a theoretical thing, because if you're drawing lines getting steeper and steeper, aren't you going to eventually draw a vertical line? Because you can't with a pencil, because lead takes up space, you can't actually show those infinitesimally small changes. But it's a good question, but technically, mathematically, it's always getting closer, but never actually becoming. But we're always keeping it open because these in-betweens, like on the one that we just answered, where was he? Right here? So is -2 supposed to be included with the increasing or the decreasing? Should I put a bracket or should I put a, well, it's in between. It's not one or the other, so we don't include it, which is why in the notes I say always keep these intervals for increasing, decreasing open, because the in-between point, it's not doing one or the other. It's not doing one or the other. Now, technically, I guess we could say this one is decreasing because it's not in between, but we're not going that picky in that particular until calculus. So we'll leave that one. Wait, notes, hold on. We were grading homework. I'm sorry. Let's go back. 52 and 54, you were just seeing if you could use your graphing calculator, because isn't there a min and max tool or option? And where do you find those?
Second trace.
Yeah, you find those options in the menu that's in the second trace or in the calc menu. So it was just seeing if you could, number 1, get a correct window, and number 2, use the min and max feature. But where's the min for that one? If you keep zooming out, yeah, it's nothing. Why? What's it going to keep on doing? The range is -infinity up to, there is no minimum. It's going to keep going down, 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 down. So even though you could have been like, that's the lowest point, well then zoom out. Well, now that's the lowest point, well zoom out. Well, now that's the lowest point. There is no min, there is no minimum boundary, because the range would be -infinity. How low? Up to, what is this? 3.08? How high? So anyway, number 54, no min, but there's the max. Number 60. I think we talked about this one yesterday, right? It's none. Why? Because it never goes above or hits the x-axis. It's always below. So that's a none. Number 80. If you knew what the graph looks like, you could easily say it has y-axis symmetry, which means the function's even. But you could have also done that cool plug in the negative and it stays the same trick. You have also plugged in the negative x and it stays the same. Hey, it's even. Number 60 is none. Talked about it yesterday. Number 80 is even because of the y-axis symmetry. And then number 86. Anybody get stuck on that one? Was there an 83 too?
Yes.
Okay. Let's go peek. Let's go peek. There he is. 83, that was an odd. So you guys could actually technically have calc chatted. It doesn't mean it's totally something that you've mastered or totally understand. But let's go to number 86 just because that one you couldn't have. Okay. You guys got the point in both of these. You were supposed to be figuring out some sort of expression for length, right? Uh-oh. Because there's like a little baby rectangle. We're trying to figure out his length as a function of y, or in the one before, his height as a function of x. So one way the rectangle is going this way, the other way the rectangle is going that way. You guys are doing this one. Let's highlight him real fast. Don't worry, these guys are definitely not on the quest tomorrow. But do you know how didn't we have a rectangle that was squished inside a semicircle at some point?
Yeah.
Inscribed in a semicircle. And we had to figure out that base times height, and the base was 2x and the height was y. All of that was based on this guy hitting at a point. So if I was to make a point for this, an arbitrary point, an x, y, like I did with that little rectangle that was fit inside that semicircle when we had that problem in section, I don't know, 1, 4, 3, something. Guys, which of these coordinates would help me out with length?
X.
I know it's hard, it depends on the picture. But wouldn't it be the horizontal x? Because it's how far over is the length of that rectangle, right? So technically, the x is what helps me with the L. Well, hold on, what are they asking for? L as a function of y. But we just said L is x. Well, hold on, no. I don't want x, I want y's. So if L is x, did they give me a clue or a piece of information that I can use to substitute?
2y.
I can plug it in. There you go. Yep. So easy it's hard. But that whole idea of x being horizontal and y being vertical, it's used in so many different types of problems, and it kind of gets harder and harder to realize how to use it. So we could go back to number 83 if you guys want. Can I go back real quick?
Yeah.
Number 83. This one, you're looking for height, and you're looking for it as a function of x. Let me try to make it bigger. Okay. If I was talking about this rectangle hitting at this point. So here's my xy. This one's a little bit trickier. What could I say about that h? How could I write an expression for that h? Am I going to use the x? Oh, wrong one. Am I going to use the x or am I going to use the y?
Both.
Yeah, but which one has more bearing on this?
Y.
The y, because isn't y a height?
Yeah.
But hold on, doesn't y come from down here? Isn't that y? So how do we get this h? If that's y, and this is my picture, how do I get h?
You just take 1. It's just 1 because it's in 2.
Careful. 1 is the x.
It's between 3 and 2, so.
It's between 3 and 2. And it can be different measurements. It can be longer or it can be shorter. So what's going to be true every time? If y gets us up to the point, and then height takes over, what would just this portion be?
3.
Careful, 3 is the whole length.
3 over 2.
No, that's okay.
If it's between 2 is 1.
But you're just doing this one rectangle and forgetting that can't there be different rectangles? We're keeping it general, we're keeping it basic. this is y. How do I get h?
Divided 3 over y.
3 minus y. Simpler than division. Division is like cutting it up into y pieces. But if I just take the length of 3 and if I take away y, whatever it is, won't I have the leftover? You see it? The whole minus the part will give me the leftover. It's hard to see. It is hard.
So it's 3 over y, but wouldn't it technically be the equation? So it would have to be 3
Exactly,
over
because we had to go back here and say, wait a minute, we want h as a function of x. So when we have h, we know how to get it. But the problem is they say, but we don't want it with y. So what are we going to do with this?
Put it in there.
Plug it in, plug it in. So it's going to be 3 minus. This was harder because it wasn't just x. It wasn't just y. It was the remainder from y to get to 3. So 3 minus y. It's a little bit crazy. It has to do with something called integration, an area between curves. If you have any people in your family or your social circles that are taking calculus, you can be like, so I saw this today. But otherwise, just one of those like, okay, it was a pre-cal skill to look at this height and say, hey, it's the whole 3 minus the part y, but I need to substitute in. Anyway, way beyond what we're going to see tomorrow in the quiz. Definitely, but it helped you guys finish off homework. Checking homework grading. But one last call. Any homework questions or any clarifications you guys want to see before we move on?
Yes.
61? Cool. And then out?
53 and 54.
53.
53, sorry.
53.
I just have a question.
Yeah, go for it.
For the maximum and minimum one, like my calculator, I put it in, but I got slightly different points.
The reason we would do that, we're actually going to see it when we do the graphing handbook. And the good news is on tomorrow's quest, you don't have any questions like that. So you don't need to stress about having to use your calculator perfectly tomorrow because you're not even using your calculator. And when we get to the handbook, I think it probably had to do with you making sure that your left bound was very left, your right bound was very right of the middle. And then when it says guess, hitting enter and making the calculator find it instead of just approximating with your cursor.
But no, I was using the guess thing, it just still gave me different numbers.
And you hit enter with the guess?
Yeah.
Can you throw one in, Emily, and I'm going to come look at it?
It just changed, like,
The
depending on how
decimals.
close left bound to the top and how close right bound to the top bound.
Just make sure one of the functions is in there and I'll come and cut it. Maybe that one with both. That might be nice. Alec, you said this one, right? And this is, oh, that's what you're asking about, huh?
Yeah.
53 and 54? Okay, so hold on, let me pull up my graphing calculator. And then the other one, Megan, you said 61? Okay. Let me do 61 real fast just because that's without the calculator. And then we'll go peek at that calculator one. So average rate of change. What did we see yesterday? Average rate of change is the same thing as finding the slope. Good. So if I'm just trying to find the slope, just thinking for tomorrow, because I'm almost positive there's an average rate of change one tomorrow. Slope is y2 minus y1 all over x2 minus x1. Like it could be that basic, right? If I give you 2 points, find the slope, sweet. But if I give you information in a weird way, you can still do this. You just have to say, oh, y is the same thing as f of that x. And y1 is the same thing as f of that x. And how does that make all the difference? Who are my x2 and x1s in this problem? 3 and 0. So what am I plugging into my f? Yeah, 3 and 0. But now you actually have to go find the y's in the graph. No, unless you want to graph your line. It might be easier just to go find the 3 and go find the 0 by, how do we do function notation again? Algebraically, plug it. Oops, that's not a 0. Plug it in, plug it in.
9.
So, I would plug in my 3. You guys have already figured out that's 9. Then you would plug in your 0. And that's 15, right? So I can plug in my 9 minus 15 all over 3 minus, which is negative 6 over 3, which is negative 2. Give me a thumbs up if you agree. You guys already solved. Okay. But Alec and then Ellie too were like, so what's going on with my calculator or with this problem? Okay, hold on. There's like an updated program that they downloaded, which was very nice of them. I just don't know how to make it look all nice and big and not the key press history. I want you to see. Oh, nope, that's not what I want. Nope, that's not what I want. There we go. Ew, but then it cut my calculator. You know what? We're just gonna make it work, yeah? Not much better. Okay, you know what? We do what we can. So in the y equals, Alec, give me number 53's equation. Don't worry, I got it. X minus 1.
Square root of x.
Square root of x. Okay. And then when we do the window, I think zoom standard is sufficient for this one.
Yeah.
Yeah. So there's only a minimum?
Yeah.
Okay. So since there's only a minimum, I could zoom in just a little bit to make it a little bit nicer on my semi-old eyes. Can I get rid of this? I don't like this.
Oh, we didn't have that problem.
Oh, you didn't have number 53?
Where did
I think I started 52, I think.
Oh. Can I go to 54 instead?
Yeah.
Okay. 54 gives me x, and then square root of, guys help me out, 4 minus x?
Yeah.
Okay, making sure that was right. Let's just clear the history because that's getting messy. And then we go to our graph. I think zoom standard is good again. Oh yeah, he's the one with no minimum and he has a maximum, right? Now, the second trace, I can use that max feature. The left bound. I was saying a second ago, make sure it's obviously left. Like, make sure that there's some, like, wiggle room, there's some space, like, obviously, obviously, obviously left. And then go obviously, obviously, go past. Ooh, he disappeared. There he is. Make sure he's obviously right to where the maximum for sure is in between. Some people cut these a little too close and they end up actually bypassing it, and that makes them have some issues. And then the guess, you can go and you can guess, but you have to hit enter because your guess is going to be off until you tell the calculator your turn. And when you say your turn, it should find it within, well, quite a few decimals of accuracy. Which would be, what, 2 2/3-ish? And 3 point, I guess you have to precisely plug in 2 2/3. But 3.079, 3 decimal places for me is usually good. Oh, so how'd it go when you tried telling me this? Alex, does that make sense?
Yeah, so I mean that's what I did. So I just thought it was kind of like too easy, so I kind of got tricked.
Oh no, that makes sense. No, that's a thing. Yeah, that's totally a thing. Because they were just trying to basically see if you knew how to use your calculator, but also that you knew how to analyze a graph, given a graph, to say like max, no min. There's the max, there's the min.
Yeah, that's what I did. I just kind of.
This one you would have had to play with the zoom a little bit, so make it a little bit harder. And this one there was no min, so they made sure that you knew that.
On the first one, I got like within a couple decimal points, but then on the second one I plugged it in. Maybe I did it wrong, or for the next one, I got like 1 point something, negative 1.93. So I don't know if it's because like I'm not.
You're going for sure to the left. Yeah,
like
and then for sure to the right. Then your
What?
guess.
Swim practice.
Yes, you're not on the swim team.
Yeah, how to make it big.
And if it's
No.
negative 1.93.
Oh.
Guys, whenever you see this on your calculator, this is for the other problem.
Right,
This is for number 52.
Good job, Ryan.
Guys, some of your calculators might do this too, depending on what's going on, and it's being done, it's being read. Just ignore that. But some of your calculators at some point are going to do something kind of, I'm making up numbers, but it's close. Whenever you see something like this, your calculator is trying really hard to give you the most precise answer possible, but it's going to be a little bit off sometimes because it's using estimation techniques to get these perfect answers. Now, if you plug in 0 to this equation, you get out 15. If you plug in 15 and solve, x is equal to 0, perfectly 0, exactly 0. But your calculator is using like these harder computer programming means of not knowing really who this is and just using the graph to zero in on the 0 within so many decimal degrees of accuracy. Guys, this is scientific notation. What's going on if you have times 10 to the negative 10th? What's your calculator really telling you? Not this, it's telling you this.
10 more zeros.
0.0000000. It got so close. No, it was still a little bit off, and it didn't make that jump for you to go to 0, but it was telling you it's 0. Does that kind of make sense? So some of the older calculators, or even some of the newer ones, you're going to have times where it tells you like e to the negative something. And if it's a lot of zeros, it tried to get as close to 0 as it could, and it didn't know it was supposed to make that jump. You have to make that mental jump of, oh, you're trying to tell me 0. Kind of cool? Yeah, no, that's a great question because, yeah, multiple calculators are going to do that this year for sure. All right, guys, with that, let me show you what I threw into your Google Classroom just a second ago. That's going to help you for tonight. I did not require, which maybe I should have, but they had a fire drill. I did not require a quiz review homework for regular pre-cal. But I am putting one for you guys because here's just the truth of the matter. Whether or not you want to believe me, it's true. How do you study? How should you study for math, tests, quizzes, quests, etc., especially as the math gets harder?
Doing more questions.
Doing more problems. Now, hold on. Is the answer just to do problems? To do them correctly, or to figure out how to do them correctly, right? So to work them out, to find mistakes, and then to go ahead and polish or study those mistakes, the ones you were making, and how to do it right. For some people, that literally means going back to the homework that we've already done, looking at blank problems, going back to homework that we've already done, looking at blank problems and trying them again, because it's like, hey, I know the answers and I know that we've gone over the questions in class. So some people, it's going back to old homework and trying the problems again until they get them right. Now, for some brains, though, that's really dangerous because sometimes you end up memorizing those problems and you get to a quiz or a test, they're different, and you get messed up because they're not the exact same. They're similar, but not the exact same. But for some of you, or I should say for all of you, another way is to go to like the chapter review that almost every math book ever has and doing strategic problems. Now, do you guys know exactly what the quest tomorrow is going to look like? No. So are you going to be able to strategically pick out which problems to do?
No.
Maybe not, but guess what I did for you? Strategically pick out problems that might be helpful for tomorrow's quest. Now, does that mean that there's going to be a problem like every single one of those that's up there? No. That's a pretty good sampling. Does that mean every single problem on tomorrow's quest is going to come from those? No, but it's a pretty good sampling. So I'm giving you a required homework. The nice thing is on any review you ever have to do with me, final review, quiz review, test reviews, you never have to write directions or givens. You just go for it. Because it saves you time and you're just like tomorrow on a test, show me the work, get me the answer, and that's it. Does that make sense? Okay. But might it be nice not just to have some strategically chosen problems you can use to review, but also maybe me holding at least some version of the test quest that's been given in the last 5 years and giving you some hints about what might be on it? Oh, but you already gave us hints. Okay, then I won't. Just kidding, you might want them anyway. I gave you some hints. Here's some other ones. Alec, you listening? The quest has 10 questions with 1 bonus. They are all multiple choice except for the bonus. But I will be looking at your work to give you partial credit. So they are multiple choice, but I will be looking at your work to give you partial credit. Because what a bummer if you miss 1 out of 10, that's 10% of your grade, right? If you miss 1 out of 10, and I didn't give partial credit. That's kind of the reality of a lot of standardized tests, but since a lot of our tests are going to be multiple choice, I look to the work to give you partial credit. But that means, if worst comes to worst, yes, guess an answer. But the best way is to have a solution that backs it up, that you can make sure you're right and I can grade for partial credit. We talked about circles. We talked about, did I put down solutions? How to test solutions? I mean, that's kind of easy, but. Symmetry. When I write down symmetry, could you study the earlier symmetry where we had test points? Yes. But should you maybe also study the whole even and odd thing and how to test for symmetry that way with function notation? Guys, speaking of function notation, when I say function notation, I mean something like, hey, here's f of x and find f of x plus 2, how to plug in and simplify without killing any poor woodland creatures. When I talk about slope, I could be meaning y2 minus y1 over x2 minus x1, or I could be meaning average rate of change, or maybe both. Ooh, did I put up zeros up there? Maybe you should put it down somewhere. Zeros. Hey, if you're trying to find the zeros of something, what are you doing? You're setting the whole thing equal to 0, which will include factoring. And when you factor, well, doesn't it get a little tricky when there's a number in front?
Yeah.
So zeros might be helpful to add. Domain might be helpful to add. And difference quotient might be helpful to add. Domain might be helpful to add. Finding the domain problems. Difference quotient might be helpful to add.
Do we put this in our table of constants?
Yes, please. That's a good question. Megan just asked if you should put the quest review in your table of contents. The answer is yes. But you do not need to write directions or givens. Just show me work and solutions. It's okay.
Since we're not allowed to have our calculators, when there's like big numbers.
No. But with the factoring problem, you might want to take out a GCF first. Might make your life a little bit easier. If you don't take out the GCF, you might have a bigger number than you would otherwise. Yeah. I didn't say increasing or decreasing. So many phone calls today. Huh. You're okay? I think you're okay. Maybe domain and range, because those are interval notations. They're not for anything else. Hello, Lydia. Okay, good. I think the office must not have runners this year. Any other questions that you guys want to ask? AKA increasing, decreasing constant is not going to be fun. Neither are the rectangles or NFL football field or boxes in the middle. Bye, guys. Study some formulas. Practice.
Bro, just stand up for a moment.
You bad?
I'll be here during lunch after school if you guys need anything. Feel free to come on by.